Okay, so let's do an example. So here we have S is the surface defined by x squared plus y squared is 1, and z gets the range between 0 and 2. So we have to evaluate the double integral. So the surface integral over the vector field f, where my f is this guy here. Or another way of reading this is the flux of f across S. Okay, so let's first draw the surface they're talking about here. So it's a unit circle in the xy, and z gets to go from 0 to 2. So if you draw that, it's going to be a cylinder. So let's draw that. So I've drawn it here. So it's a cylinder. So it's the unit circle. Unit circle's going up, and the z can go from 0 to 2. So this guy is 2 here. And it's just the surface of the cylinder, so not the inside, just the surface of it here. Okay, so let's parameterize this. So to parameterize the unit circle, the x squared plus y squared equals 1, we're going to say let x equal cosine, let's call it u, and y equal sine of u, and say z equals v. So doing that, then r of uv would be cosine of u sine u v. Okay, so this is going to define our D region, so let's draw our D region. So my D region will be like this, so it's in the UV plane. So the angle, well, to pick up the whole unit circle is going to have to go from 0 to 2 pi. And then the V value, well, is equal to Z, so it's going to range from 0 to 2. So this D then will map onto R into the cylinder. Okay, let's keep going. So now let's find partial derivative of R with respect to U. So derivative here will be derivative cosine will be minus sine. And so derivative sine would be cosine. And derivative of V would be 0. Okay, let's also find derivative of R with respect to V. So the first guy, the cosine doesn't have a v, so it'd be 0. The sine doesn't have a v, so it's 0 also. And derivative of v with respect to v is 1. Okay, so now let's do the cross product of ru cross rv. Let's do that. Okay, so I got my cross product here. So I got ij and k on top, and then I have ru, rv here. So let's do the cross product here. So do the I one first. Recover this. So let's do it over here. So it's going to be cosine u 0, 0, 1. That's I. Then doing j, we then minus. So j would be minus sine 0, 0, 1, be j, and then plus the k1. So it'll be then negative sine u cosine u 0, 0, k. So that'd be cosine times 1 and 0 times 0, so we just cosine here. So it'd be cosine ui. Then here it'll be negative sine u times 1 will be negative, which is minus in front here also, so it'll be plus sine u j, and it'll be 0k. Okay, so let's keep going. I'm going to erase some things here now. Okay, so summarizing this, what we have so far, I have my f up here, I have my RU cross RV. We have our R here. So again, here we're looking for the flux of F over across S. Okay, and we've shown in 15.6 that we can find the flux using this right here, where D is this region right here. So let's start filling this in. So it's going to be then integral. Well, the V is going to go. This is a V here, and U. So the V goes from 0 to 2. The U goes from 0 to 2 pi. It's going to be F of R, F composed of R. So pretty much that'll be my X, that'll be my Y, that'll be my Z. So plugging into the, up here into your F function will be 2 times X. It'll be 2 times X, but X now is cosine. Times Z, but Z here is V. That would be I direction. Plus Y squared, but Y now is sine, so it'll be sine U squared minus X. X is cosine. That will be J. And plus phi times Y, up here 5Y. Y is sine, so it'll be phi times sine. 5 sine of U. Okay, and this thing's dotted with now our RU cross RV, which is right here. So it'll be cosine U I plus sine U J plus 0K. And then we'll have our du dv. Okay, so let's do this dot product now. So dotting here, the I components is going to be then integral 0 to 2, integral 0 to 2 pi. So dotting, you'll have 2 cosine squared V times V, and then it'll be sine times sine squared times this. So multiplying that in, it'll be plus, be sine times sine squared, it'll be sine cubed. And it'll be sine times minus, cosines will be minus sine cosine, or cosine sine. Now it'll be 0 times this will be nothing there, so it'll be just this right here. Okay, so to integrate a trig function to an even power, so like a cosine squared or to the fourth, or sine to the squared or to the fourth, by itself, you're going to make a double angle substitution. So we're going to replace cosine squared with this guy, 1 plus cosine 2u over 2. And here we have a trig function to an odd power, so to handle that is, you're going to break it up as sine squared times sine, then replace the sine squared with 1 minus cosine squared. So we're going to make that substitution for sine cubed here. So let's do that. So making those substitutions then from up here, we get this. I've broken it to integrals because the second part over here, we're going to do a W substitution. So in the second part, we're going to let W equal cosine of U. So then dW du will be negative sine of U. So negative dW then will be sine U du. Okay, so in here the 2's cancel. Okay, so let's keep going now with this. So let's make these substitutions, change the W's then. Okay, so making the substitutions, we get this, where again W is cosine of U. So then W of 0 would be cosine of 0, which would be 1. And W of pi over 2 would be cosine of pi over 2, that's also 1. Okay, well we got 1 here and 1 here. That's going to make this entire thing equal to 0. Okay, so we just have this guy remaining over here. So integrating this. So integrating this, we get this. So because the integral of 1 would be u. The integral of cosine of 2u would be sine of 2u over 2. You could check that. You could do a u substitution, but you can check it's going to be this. I won't go through it. So let's evaluate this now at 2 pi and 0. So doing that. So putting 2 pi in place of u here. Putting 2 pi in place of u here become 4 sine of 4 pi. Then putting 0 in place of u, so 0 here. 0 in place of u up here, sine of 0 over 2. So the sine of 0 is 0. So this is 0 here. Sine of 4 pi is also 0. Okay, so we just get 2 pi then, so it would be then equals integral 0 to 2 of 2 pi dv, which would be 2 pi v evaluated at 0 and 2. So putting 2 in place of v would just become 4 pi. So 4 pi is our answer. So that would be the flux of F across our surface S. So our surface S here was the cylinder. Okay, so we're done.